Section 4.1, video, part 1. The title of this section is called inverse functions, but we won't initially start out talking about inverse functions because I've got a couple other things I have to talk with you about before we get to inverse functions. But before we even get to that, I want to talk to you about a special type of function called a one-to-one function. Called a one-to-one function. All right, so what I want to do first is give you the definition of a one-to-one function. Before I do that, let me go back and remind you out of section 2.3, let me remind you of what the definition of a function is. Well, let me back up even a little bit further than that. Let's talk about what a relation is. A relation, we said that a relation is just simply any way that you can represent ordered pairs. And I told you that there's three kinds of relations. Ordered pairs, if I give you a set of 8 or 10 ordered pairs, that's a relation. Any graph is a relation because what is a graph made up of? A bunch of points. And then any equation with two variables. That is a relation. Because if it has two variables, your answers are ordered pairs. So a relation can be ordered pairs, graphs, or equations. Then we moved on and we talked about domain and range. And then we talked about functions. Now, what was a function? Well, if you're talking about ordered pairs, a set of ordered pairs was a function as long as the x's did not repeat. Now, could the y's repeat? Yes, but the x's couldn't. So if you're talking about ordered pairs, the x's can't repeat. If you're talking about a graph, what did a graph have to do in order to be a function? It had to pass the vertical line test. Remember, you draw as many vertical lines as you want to, and if you can find one vertical line, that you can draw that intersects that graph more than once, then that graph is not a function. But if every vertical line you draw intersects the graph a maximum of one time, at most once, then it passes the vertical line test and it's a function. Now, what do we talk about the equation? Now, remember, it was a little different. The equation, remember, the biggest power of y could not be even. It can be odd, but it couldn't be even. And y can't be inside absolute values. All right, so here's what we're about to do now. We're not going to revisit function. We're going to talk about a one-to-one function. Now, let me first of all state the obvious. A one-to-one function is, first of all, got to be a function. That means the x's can't repeat, means it's got to pass the vertical line test, and it means the biggest power of y can't be even and it can't be in absolute values. A one-to-one function has to have those same characteristics because it has to be a function. That would be like saying a red car. Does a red car have to be a car? Well, sure it does, because it's a red car. So a one-to-one function has to be a function, but it has other characteristics about it. And the idea of what it says here is one-to-one kind of tells you what I'm about to define. So I want you to take this note down, kind of a lengthy note. I will pause in my sentences where you'll know where to pause the video. Okay, here's the definition. A set of ordered pairs is a one-to-one function if neither the x's nor the y's repeat. Okay, so a function says the x's can't repeat. A one-to-one function says neither one of them can repeat. And by the way, the idea of what it says, a one-to-one function, tells you its name. So if x7 is paired with 5, the number 7 will never repeat again and be paired with anything else. But if 7 is paired with 5, 5 will never appear as a second number ever again, and it's only paired with 7. And so that one x will never be paired but with that one y, and that one y will only be paired with that one x. So neither one of them can repeat in a one-to-one function. Continue the note. The graph of a one-to-one function must pass the vertical line test and horizontal line test. So it's got to pass the vertical line test because that means it's a function. Now, how does the horizontal line test work? Horizontal line test works the same way. You just draw your lines this way. So if you can draw one horizontal line that touches twice, it fails. Now, why does it work that way? I showed you this before, but let me remind you. Remember, if you draw a vertical line and it touches the graph at 2 places, that means those x's repeat. Well, if you draw a horizontal line and it touches 2 points on your graph, those 2 points have the same second number. And so it's got to pass both line tests to be a one-to-one function. Now the last part of the note. An equation with 2 variables is a one-to-one function if the biggest power of y is not even or in absolute values, and the biggest power of x is not even or in absolute values. So do you notice the definition? You've got the definition of a function, and then a one-to-one function is all of those things carrying it one step farther. Okay, function, x's can't repeat. One-to-one function, x's nor the y's can repeat. Graph, for it to be a function, pass the vertical line test. Graph, for it to be a one-to-one function, the vertical line test and the horizontal line test. Equation, y can't have a highest power even or be an absolute value. One-to-one function, y can't be, highest power can't be even or in absolute value, but nor can the x. So it's the same definition, you're just carrying it one step farther in each of those 3 cases. All right, so what I'm about to do is I'm going to put these problems up, write these instructions down at the top. Well, you can probably just pause the video. Give me just a second. Let me make sure you've got every graph on here. Okay. Let's see if that got it. Yes, it did. Okay, pause the video now and copy these examples. Okay, so I'm assuming you just copied these examples. Now the question is, are these one-to-one functions? Well, let's look at ordered pairs first. Let's look at A, example A. First, is it a function? Do the x's repeat? 2, 5, 8, and 0. So this is a function because the x's don't repeat. Now, do the y's repeat? -3, 2, 11, -9. None of the y's repeat. So A, right out beside here, write, yes, it's a one-to-one function. And when you write it, say this, yes, it's a one-to-one function because the x's nor the y's repeat. So write that reasoning out so you'll remember why you said yes. All right, let's look at this next one. 4, -3, 8, 0. It's a function. 1, 9, 2, 9. The y's repeat. So the answer to B, is it a function? Yes. But the question was, is it a one-to-one function? So the answer to B is no, because the y's repeat. All right, let's look at C. Okay, you've got three graphs here. Let's look at this one. Does this pass the vertical line test? Yes. So that's a function. Does it pass the horizontal line test? Yes. So the answer to C, write yes. And then beside that, write passes VLT and HLT. Okay, D. Is it a function? Yes. But is it a one-to-one function? No, because it fails the horizontal line test. So the answer to D would be no, fails HLT. Now, if I had asked, is this a function, the answer would be yes, but it's not a one-to-one function. All right, now this next example. This next example, is it a function? No, fails the vertical line test. So if it's not a function, is there any way it can be a one-to-one function? No. So this problem right here is no, fails vertical line test. Okay? Now F. First, is it a function? Biggest power of y cannot be even. It's not. Y can't be in absolute values. It's not. So this is a function. But that's not the question. The question, is it a one-to-one function? So now check the x's. Biggest power of x is not even, and x is not in absolute values. So this one right here is yes. That's a one-to-one function. Now let's look at this one. G. Biggest power of y is even. So this is not a function. So if it's not a function, is there any way that it can be a one-to-one function? No. So the answer to G would be no, and then you could say because it's not even a function. All right, H. Is it a function? Biggest power of y is not even, and y is not in absolute value. So this is a function. But is it a one-to-one function? Now check the x's. Biggest power of x is even, so no. This is not a one-to-one function. It's a function, but it's not a one-to-one function because of that even power on x. Now, I'll come back in just a minute and talk to you in just a second about why I just went over that with you. Now what I want to do is yak with you for a few minutes about inverse functions, because that's really the goal of this section. So what we want to talk about in this section is we want to talk about inverse functions. Now first of all, whenever you talk about inverse function, you're always talking about two functions, not just one. Let me give you a couple of examples. Let's suppose I owned a factory that had a warehouse that put furniture together. And so down on this end, you had a machine that took and put a screw in the board so that you put it together. So you have a machine down here that puts the screw in. Then when it comes on down the assembly line, they get ready to pack it up. And so you have a machine down on the end that takes the screw back out. Those two machines are inverse functions of each other. What one does, the other does just the opposite. That's what inverse function does. In the English world, we talk about inverse functions in the English world, but we don't use the word inverse. In the English world, we use the word antonym or opposites. For instance, if I said, what is the opposite of hot? You would say cold. That's two words. What's the opposite of up? It's down. What's the opposite of left? It's right. So those are antonyms of each other. Now let's come back to mathematics. So an inverse function basically does this. An inverse function does just the opposite of what some other function does. So if this function does just the opposite of this one, and if this function does just the opposite of this one, these two functions are called inverse functions. Now, I'll show you in just a minute what I mean by if they do the opposites of each other. I'll talk about that in just a few minutes. But before I do that, now let me talk to you about why we just talked about one-to-one functions. It turns out some functions have an inverse function, but some don't have an inverse function. It's that way in English. If I ask you what's the opposite of up, you would say down. But if I said what is the opposite of carpet? What is the opposite of desk? What is the opposite of pink? There are some words in the English language that don't have an opposite. Well, in mathematics, there are some functions that have inverse functions, and there's some that don't have inverse functions. Now, what we're about to do in a few minutes is we're about to practice finding the inverse function if it has one. But what we need to know beforehand is, how do we know it even has one? Because I don't want to spend time looking for an inverse function if it doesn't have one. So that's the note I want to give you right now, and you'll see why we just covered what we did. Take this note down. Only one-to-one functions have inverse functions. Only one-to-one functions have inverse functions. So, let's look back at the problems we just did. You don't have to, look back at the ones we just said no to. Remember this one right here? This one was no, because the 9's repeat. So, would that have an inverse function? No, it doesn't. This one was no, because it failed the vertical line test. This one would not have an inverse function. This one was no, because it wasn't even a function. So that one would not have an inverse function. This one would not have an inverse function. So let me state it again. Only a function that is one-to-one will have an inverse function. Now, before I go any further, let me go ahead and make it even easier than that for you. I will not give you any problems where it doesn't have an inverse function. If I say, find the inverse function, particularly if we're talking about equations, I will make sure that it has an inverse function. Now, like this one right here, I would expect you to know that that one doesn't have the inverse function. Ordered pairs are always easy. But when we get to these problems, that'll be a little bit different. But anyway, so only a function that is one, that's the main thing, the takeaway from what you just wrote down, is only a function that is a one-to-one function has an inverse function. If it's not a one-to-one function, it can't have an inverse function. Let me just show you right quick why while we're right here. Let me ask you this question. Is example B right here, is it a function? Yes, it's a function because the x's don't repeat. Now, here's what you're about to learn in just a few minutes. What happens in an inverse function is this. If x is 7 and y is 10, so if you have the ordered pair 7, 10, what would a function that inverts it, what would it do to that ordered pair? It would swap your numbers around. So in a function, if you have 7, 10, here's what the inverse function would do. 10, 7. If you have 3, 5 in a function, what would you have in the inverse function? 5, 3. Now, let's come back to this. Ask the question again. Is this a function? Yes, it's a function. Is it a one-to-one function? No, because of the repeating 9's. So this is not a one-to-one function. We've already said that. Now, if it's not a one-to-one function, does it have an inverse function? No, we just said it has to be a one-to-one function to have an inverse function. I'm just going to show you why now. If you invert these ordered pairs, which is what the inverse does, this 9 now goes first. This 9 goes first. So you had repeating y's, but when you invert them, now you have repeating what? X's. If you have repeating x's, it's not even a what? Not even a function. So if you have repeating x's, if it's not a function, how can you call it an inverse function? So that's why for a function to have an inverse function, it has to be one-to-one. In other words, the x's can't repeat, the y's can't repeat. That way when you flip the ordered pairs, you still, none of the x's repeat, none of the y's repeat. Okay. So this is a good place to land. We'll stop here with this video and we will pick up in the next video still talking about inverse functions.